welcome to another video of the MSU Denver video walkthrough of the Elementary Acupressure Study Guide. In this video, we're going to be talking about graphing linear equations. And there's a few ways to do this depending on the information you're given, but for this video, for this test, we're going to focus on what we call the slope-intercept form, because that's what we can use, and it's the easiest way to do it with the information that we're given. And honestly, it's the easiest way to do it, so if you can do it. And what the slope-intercept form is, if you remember this, we call it y equals mx plus b, so maybe you're familiar with that. And if you're not, that's okay, but if you are, that's great. In this equation, the slope-intercept equation, y and x are just our variables, and those are going to change, and that's how we get a line. And then m, we talked about it being slope-intercept form. M is going to be our slope, right? The slope of our linear line, our straight line, which isn't going to change because it's straight. And so it's our slope. We also call it rise over run. And I use rise over run because talking about it like that will help us when we're actually kind of plotting the graph. It helps us with what we're doing. And you might also have heard of it as the change in y, delta y, the little triangle just means change, over delta x, the change in x values. And the only reason I say that is if you've seen it like that, well, it is the same thing. If you haven't seen that, if you're not familiar with that, that's okay. Don't worry about that. Just really kind of recognize it's rise over run. And if m is our slope, and we're talking about slope-intercept form, well, then b should be an intercept. And in fact, b is the y-intercept. And what that means is it's the value of y. I guess I'll write this out. The value of y when the line crosses the y-axis, and that's where x equals 0. So this b, your coordinate, and this is why it's nice to know what b is and have it in this form, it's always going to be x is equal to 0. So if I put it in coordinates, it's x comma y, right? Our coordinates are x comma y, and it's always going to be 0 for our y-intercept, and then it's whatever number b is, and b is going to be a number, whether it's 5 or 10 or 1,000, depending on what you're looking at, or maybe even 0.005, whatever. It's going to be a number though, and it could be even 0, right? If it's 0, then the line crosses at 0, 0, which is origin, and we'll see that. But yeah, b is where the value of y, wherever it crosses that y-axis, and we'll see that in just a second. Because before we get into the practice problems, I'm going to do a little practice problem of my own, just so we can kind of talk through it. And so the practice problem that we're going to do, just so I can kind of move through it, is 4x minus 2y, and this is not in the book. If you are following along in the book, which you should be doing, we're on page number 19, and the practice problems that we're going to be doing are on the bottom of that page. This one's not in there. I just made this one up. But 4x minus 2y equals negative 2. And so the first step that we want to do within any of these problems, right, is get it into y equals, right? And when you get into y equals, it should fall into, because of what the information that they're giving you, it should fall into y equals mx plus b. So solve for y. And based on previous videos, you should know how to do this. If you're not comfortable solving for y, you should go watch back and watch the previous videos. But I'm just going to do this all in one step real quick. Y equals, I'm going to move the 4x to the other side, so I get negative 4x. I got to divide by negative 2, so I get 2x, and then negative 2 divided by the negative 2 is plus 1. So y equals 2x plus 1. And I'm just going to show you something real quick. You might have solved it. You might have gotten, if you did it on your own, it's step by step, you might have gotten y equals 1 plus 2x, and that's perfectly okay. That's the same thing. I always have the x's first, and I have the highest exponent of x first, the leading exponent. That's just typically how you write it. And by having the x first, it really kind of exemplifies what our y equals mx plus b is. It's a lot easier to see. So if you have y equals 1 plus 2x, just kind of switch it around and have write it as y equals 2x plus 1. And you might ask yourself, well, in some occasions, oops, I erased the y. In some cases, they might actually give you y equals, and it's already set up for you, and you're good to go. But if they don't, then you have to solve for it. So now that I have y equals something, right, before I start graphing this, I need to figure out what my m and my y are. Now, or my m and my b are, my y-intercept. And b is pretty simple, it's just whatever this number is. So in here it's 1, and if it was a -1, it'd be a -1. You include the sign on it. Excuse me. And if it was a fraction, you include the fraction. I don't think we're going to see any fractions. We are going to see a fraction in one of our examples. So it's a fraction. It's a fraction. It is what it is. We keep it as fractions. We don't put it at a decimal because we don't have a calculator in this for this test. And my m, which is a little bit more difficult to kind of talk about, a little bit longer, it's 2, right? But before I was talking about rise over run. So if I want to speak to it as rise over run form, right? If it's a fraction, if you have like y equals 1/2 x, it's actually a lot easier because it's already in rise over run form, right? And so don't be worried if you see a fraction for your m. It's actually kind of nice. If it was a negative, like a -2x, I would include the -2 here. That would be a -2. It's not, so I didn't. But if you have a whole number, you can always change it into a fraction. Remember, you can always change a whole number into a fraction by just putting it over 1, right? 2 over 1. And that's what you want to do. I mean, if you're really comfortable with this already, then obviously you don't need to do this, and you're like, okay, this guy's going off the cliff. But if you are, or if you're not, I'm kind of like walking you through, and this is what you want to do if you're not super comfortable with these problems. Put it as 2 over 1, and then realize it's rise over run, like we've been talking about. And so our rise would then be 2, and our run would be 1. So this is our 1. And I don't like to do this in the middle of a problem, but I'm going to just, let's pretend for a second our m was equal to, and I'll erase this, but our m is equal to, let's say, we'll just go -2. Then I would write it as -2 over 1. And here's the important thing, right? If I have a negative fraction, I could write this as -2 over a +1, right? And so in this case, our rise would be -2, which means we'd be going down 2, and we'll talk about what that means. And then our run is positive, so if our run is positive, we go to the right. If it's negative, we go to the left. And so, but I could also write this as 2 over -1, right? These are all the same numbers. These are all -2. And so in this case, our rise is positive, and our run is negative. And so our rise would be up, and our run would be to the left. And so I'll erase that now for our made-up slope. But it's important to realize that we can change the negatives, and we'll see that later. But we can also, just kind of a quick tag on to that, is that even though I have 2 over 1, and that's equal to 2, and that's great, I can also write this as -2 over -1. And if that's really kind of blowing your mind, don't worry about that. It is, I mean, you have negative divided by negative, so that shouldn't blow your mind. But it's extra stuff, and you don't need to do that. But it's important to kind of realize that that does work out, and we'll see why. If I graph this now, because I have my m and I have my b, I can draw a graphing. And for the test, it's multiple choice, right? So this doesn't need to be super pretty. You want it to be accurate, but you're not going to be turning it in for some professor to grade. You're just you're going to compare your graph against the multiple choices and see which one fits your graph. And so what I'm going to do first is I'm going to graph b first. And b is 1, and I said earlier that if whatever b is, our coordinate would be 0, comma b. So b is 1, so 0, comma 1. So that's our coordinate, and 0, comma 1 is right here on the graph, right? We're going to go up 1, and this is our 0, and I'll jot down a few more numbers for us. That's x, this is y. You should label your axes. -1, -2, and again, it doesn't have to be like super scaled correctly, but it should make sense to you. All right, and then so since we got 1 point down, for a linear graph, and that's what you're gonna be doing on this test. You're just gonna be graphing straight lines. Well, if you have a straight line, you just need 2 points. You plot a ruler down, you connect the 2 dots, and they go on forever, and then you're good. So you only need 2 points. You don't need a ruler because again, it doesn't have to be super straight or anything like that. But you need 2 points. And to get our second point from our y-intercept, we use our slope, right? And so our slope, in this case, our slope is 2 over 1. So our rise is 2. So I better put some more stuff there. And over to the right 1, because it's +1, so to the right 1. So if I go up 2 to the right 1, my next point is right there, and then I'm done, right? Like I just kind of sketch a line like that and put arrows on the end because they go on forever because we don't have any bounds yet. And that's it. That's my line. And so you know, you could kind of sketch more points and you can make it look prettier. But again, you're not turning this in, right? You're comparing this to one of the multiple choices, and you're saying which one looks like this, and it should be fairly intuitive which one matches your graph. It's not going to be like super close. Well, this one's like, oh, this one's 2.1 over 1. The rise over 1, right? It's going to be kind of different, and you'll see that when we do the practice problems and you check the answers. But that's the graph. That's it. But the reason I wrote down, right here, if you look at that, -2 over -1, is because if I use this and my rise is now -2 and my run is now -1, and if we say to ourselves, well, -2 divided by -1 is 2, that's our m, so this is true. Well, if I go down 2, so I go down 2 to -1, and then left 1, because it's -1, I go right here, and again, assuming we had a ruler and we drew it correctly and everything was spaced really nice, that this line would go exactly through that line right there, and we can keep going in that direction, we can keep going in the positive direction, but it goes in either direction, and that's why the negatives work as well. So that's the little example. We'll move on to the practice problems, but that's it. You'll match this graph with one that you see as a choice, A, B, C, or D, or maybe E, I don't know. I think it's just 4. So moving on to the practice problems. With the practice problems, I am going to be doing number 1, and then number 5, 6, and 7. Honestly, number 2, 3, and 4 is probably what you're going to see it as. 5 and 6 are a little tricky. 7 is also one that you might see it as, so I'll walk through that one. But I want to go over 5 and 6 because they're a little tricky. And I want to give you the ones to go over that you might see, so you can get used to it and you know how to do it. Solve for y, graph it, and then check it in the back. If you have any questions on those, by all means, please come into the tutoring center and we'll walk you through it. But number 1, going down to the practice problems, is just y equals x, right? Well, it's solved for y already, and so I should already have it in my y equals mx plus b because I told you it would fall into that. But and if you can see that, great. But if you can't, well, let's explore this a little bit. Let's try to turn it into y equals mx plus b. I could say y equals, and I could say, well, 1 times x is still x, right? I'm not going to write that one because 1 times anything is just itself. So that's kind of redundant to write that. But if I do write it, I can see that now I have a 1 there, and my m would be 1, right? So if you ever have nothing in front of something, and that something's still there, so you can't say, well, it's 0, because 0 times the x would get rid of the x. But if there's no coefficient, it's just a 1, because they don't write down the 1. If it's ever anything other than a 1, they have to write it down, right? If it was a 2, a 5, an 8, or even like a 1/2, right? They would have to write that down in front of the x. And so if there's never not anything there, it's a 1. And then plus, well, I could add a 0 here, right? And that doesn't do anything. I don't know why I would want to do that. But if I do it, I can kind of say, well, there's a number. 0 is a number, right? And so my b would be equal to 0. And so in this sense here, from this, when we rewrote it as that, and maybe you can see it right from the beginning, but m is just equal to 1. I want to turn that into a fraction, so I'm going to say 1 over 1. And if you want to get all wonky, and kind of crazy, we can say that's -1 over -1, right? Again, you don't have to do that if you're not comfortable with that, because you can just get 2 points with this slope right here. But that does work, the -1 over -1. And then our b is simply 0, right? And you will always have a b, right? If it's 0, you still want to write that down. If I graph this now, because this is the whole point of these problems, is to graph it, and that's not a very straight line, but we're going to go with it. I'll shoot that over there and that over there. The first thing I want to do is graph my b, my y-intercept. Remember, it's 0, comma b, so in this case it's 0, comma 0, because b is 0. So there's a dot, 0, 0, and that's just the origin right there. And then if we look over here, I'm going to only do this once. I'm not going to keep doing this, but my rise is 1 and my run is 1, and you want to get comfortable kind of knowing that. And they're both positive, so my run's going to be in the right direction. My rise is going to be up direction for this one. If I use this one over here, it would be different. So I go up 1 and to the right 1, and I have a point there. And then I'm just going to sketch a line between those, put arrowheads on the end of them, and call it good. And I just check that whichever matches A, B, C, or D, and that's good. You can put more numbers on if you'd like, but since you're not turning this in, it's not necessary, right? I could say, oh, that's 2, as long as you space them the same, that's 2. It doesn't matter. Nobody's going to be looking at this but you. All right, moving on to I'm going to leave you guys with 2, 3, and 4. So moving on to number 5, this might look a little weird. and I'm actually going to be doing 5 and 6 on the same graph. Oops, I'm doing number 5 and there's no y in it, right? So number 5, it's not y equals, it's x equals 5. And I said, hey, yeah, get into y equals mx plus b. And you're like, well, there's no y, right? So in this particular case, when there's no y, you just kind of think about what happens, right? So I'm gonna sketch a graph. I'm gonna go straight into draw my graph. I'm not gonna try and find my b or my m, because they don't exist in this case. So I simply asked myself, I said, well, what if y was 0, right? Because on any, it's not the best thing to do, because you're not always going to come out with like a really like detailed graph. But if you ever need to just make your x, y like a little chart like this, I can just plug in numbers. Even if it's an equation, I can say, well, when x is 0, what is y? When x is 1, what is y? When x is negative 1, what is y? And just plug down numbers and then kind of graph those out, because I just solved for y or whatever. And you can do that, but and with straight lines, it's absolutely okay, because you just have 2 points and you just connect the dots, right? Well, with non-straight lines, so if I have a graph that looks like this, I might have a dot, here and here and here, if that's what I, choose my 3 points or whatever, and that doesn't really give a good indication of what the actual graph looks like, right? So it's not always the best thing to do, but you can do it if you're kind of at a loss for what to do, and with straight lines, it actually works. And so that's what I'm going to do here. I'm going to say, well, what if y, and I can't say what if x is this, but what if y is 0, right? And when y is 0, we're at this x-axis right here, right? I should label these, right? And so if y is 0, well then I say, well, what if I plug in y 0 for y? Well, there's no y, so x is equal to 5. Okay, so there's a point. If I call that 5, there's a point right there, 0, 5. And then I say, well, what about when y is 1? And I say, okay, well, when y is 1, so that goes up here. And then I say, well, what is x? Well, again, there's no y, it doesn't change, so x is 5. And so I can keep doing this with every number, but you'll see that I'm just going to get a straight up and down line right here, just like that. And that's it. It goes on forever. Again, assuming you don't set up any boundaries or anything like that, but that's it, right? So in the back of the book, you'll see it kind of stretches the whole graph. But that's it. That's what that one stands. So if you ever have an x equals some number, that's what it's going to be a vertical line at that number. And if you think about b, well, b is where it intersects the y-axis over here, right? And if it's a vertical line that never changes, then it's never going to intersect that line. So there's no b. All right, in this case, it's not even just 0. I said you always have a b. Not necessarily, right? If it's a vertical line, you won't have a b. And then the slope, if we think about the slope being, and again, if this doesn't make any sense to you, that's okay. But if the slope is the change in y over the change in x, so the change in y, you say, oh, well, the change in y between this point and this point, that's 1. So we say, well, 1 over the change in x, and the change in x, it doesn't change, right? So over 0, and you can't divide by 0, right? And so in this case, there's no slope either. It's a vertical line. And so we wouldn't call this a function. You could still graph it. You can graph circles, and they're not technically functions because they don't pass the vertical line test. But if that makes sense to you, great. If it doesn't, okay. And then going on to number 6, we'll do number 6 on the same graph. I'm going to write that right over here. Number 6, and that's just y equals, so it's kind of the opposite. Y equals negative 2.5, right? And so you're doing the same kind of thing. You're going to say, oh, when x equals this, when x equals this, what does y equal? And in fact, any number that you plug in for x, I'm going to just kind of move that out of the way, actually. Let me draw a line and say that's negative 2.5. Any number you plug in, you're gonna say, okay, well, if I plug in 0 for x, if I plug in 1 for x, 2 for x, whatever, it's just going to be a horizontal line at that number. And so this line looks like this. And so if you ever have a y equals, some number with no x's or whatever, then it's going to be a horizontal line. And that's 5 and 6. And then you look at the trick. And you may see that on a test, you may not. But the reason that I'm throwing it in here is just because it's good stuff to know. If you have x equals, it's going to be a vertical line. If you have a y equals, it's going to be a horizontal line, assuming there's no other variables in there. All right, so moving on to number 7, the last practice problem. We have x plus 6y equals 7. And the reason I wanted to do this one is because we're going to have we have to solve for y first of all, but we're going to have some fractions in there. And so we're going to deal with fractions. some negative numbers. Good stuff. So the first thing I want to do is solve for y, and again, I'm just going to do it in one step, but I have y equals, and then if I solve for y, I'm going to have negative x divided by 6 plus 7 divided by 6, and that's correct, right? That's good, but because I want it into y equals mx plus b, I want some number out in front of x and not x divided by some number. So instead I'm going to write this as y equals, and I could write this as negative 1/6 times x plus 7 over 6. I just kind of move the x off to the side, and I put a 1 in its place. And really, if I say that this is x over 1 and I multiply the fractions together, I would get negative x over 6. And so you really want to get comfortable doing this, because whenever you solve for y, you're typically, if it's going to be a fraction, you're going to have something like that, and you want to be able to change it into something like that, where x is just off to the side. So get comfortable kind of undoing that, undoing, just kind of moving x off to the side and turning it into a fraction times x, right? And you can do that when x is on top. If x is on the bottom, it'd get really weird, and we'd have to do something different. But that wouldn't be a linear line anyway, so don't worry about that. But now we have it in y equals mx plus b form, right? And m doesn't look super pretty, and b doesn't look super pretty, but it is what it is, right? And so talking about m and b, m is equal to negative 1 over 6. And remember when I was talking about that before, I could say that this is negative 1 over positive 6, and I could also say that this is 1 over negative 6. And before, when we had positive, remember, typically you just want to keep it positive, and it makes things easier. But this one, you're really going to have to choose the negative to go somewhere, and it doesn't matter where, because again, you're only looking for 2 points. But I write both down because you could choose either one, and it's important to realize that. B is equal to 7/6, and that's not super great because it's a fraction, but it is what it is. And let's graph it. Let's see what it looks like, right? And again, yours doesn't have to be super precise. Get out a calculator and a measuring tool, and it just has to kind of look like it should look. And what I mean by that is, well, let's graph it. Let's see what happens here. I'm not an artist. I apologize. Boom. All right. So this is x. This is y. And the first thing you do is you want to graph b, and it's 0 comma b, so 0 comma 7 over 6, and I don't know what 7 over 6 is, but it's a little bit more than 1. So I'll just call that 1 and put my dot, I don't know, right there. And we'll call that 2, 1/6 of the way to 2, and that's not super accurate because it's like a fourth of the way, maybe a third of the way, but as long as it's a little bit above 1, as long as you kind of hit the ballpark, we're good. And then I use my slope, and so my slope, I can use this one, and I'll actually do both of them here. I'm going to go, this is negative 1 over positive 6, so down 1 to the right 6. So if I go down 1, I'm going to end up right above the 0, so right there. And I got to go over 2, 3, 4, 5, 6. So right around there. And then I just sketch my graph out. If I can do that, because it's kind of long. There we go. Again, I'm not claiming to be an artist. All right, so that's my graph right there, right? If you use the negative 1 over 6. If I use the 1 over negative 6, which you can absolutely do, I'm going to go up 1 because it's a positive one, so it's going to be right around there, just a little bit above 1, or I'm sorry, a little bit above 2. And then I got to go negative 6, so to the left 6. So 1, 2, 3, 4, 5, 6. So that's negative 6, and you want to label these. And then so I'm going to go all the way out here and up to this end, assuming I can kind of guess not guess, but all right, eyeball it. And then this line should go straight through that. Again, assuming you had a ruler or something like that, it would do that, and everything was even. And that's what our line would look like going using the 1 over negative 6. And you can use either or whatever. You can use both if you really want to. But that's what your graph will look like, and that's what should match one of the options in the back. And so that's number 7. Now, I'm actually going to stop this video here, but the next section is graphing inequalities, which I'll talk about a little bit about what that does. But it's the exact same graph. So I'm going to come back to this same kind of written stuff out here and just change these graphs to inequalities, because it's really the same thing, just a little bit different, little tweaks to it. So I'm going to stop that there. If you have any questions, please come into the MSU Denver Tutoring Center.